This video will help you identify independent variables and dependent variables. So first of all, let's recap what an independent variable is. So an independent variable is the variable that we have more freedom to choose or control, whereas the dependent variable is determined by the independent variable. So let's take a look at an example. Let's say a tree grows 20 centimeters every year, and we need to identify the independent and the dependent variable. So to help us with this, it would be wise to write a statement like this. The height of the tree depends on the number of years the tree grows. Okay, so we have to think if that makes sense or if this would make sense. So if I flip the problem around and now I have the number of years a tree grows depends on the height of the tree. That doesn't really make sense, that the number of years a tree grows is dependent on the height of the tree. That doesn't make sense. What makes more sense would be our original way we wrote it. The height of the tree is dependent. So how tall the tree is depends on the number of years that the tree is growing. So the longer the tree grows, we expect the height of the tree to be taller. So since we wrote our statement here, the height of the tree is depending. So our dependent variable is the height of the tree, and our independent variable is the number of years. So if you think back to our definition here, the value that we can have more freedom to choose, well, in this scenario, we have more freedom to choose how long we're going to let the tree grow. That's our independent. I have more control over that rather than the height of the tree. Now, if I were to write an equation for a tree grows 20 centimeters every year, if I let x be the number of years, and typically the x is our independent variable, and we said that the independent variable was the number of years, and our dependent is our y. Now, if I write the equation for this, it would look like this. We'd have the height of the tree is equal to a tree is growing 20 centimeters every year. So every year, 20 centimeters plus 20 every year, but we don't know how many years, so that is what x is. So when we add the same number over and over again, that's the same thing as multiplication. So if we take 20 centimeters and multiply it by the number of years, this would be our equation. Now, we said that x, the number of years, is independent. So as you can see here, that the y, which is our dependent variable, is the one over here by itself here. In other words, to get the output here, the y, we have to take the number of years and multiply it by 20. So the height of the tree is dependent on this happening here, that we have to take 20 and multiply it by the number of years to get the height. So the x is the independent and the y is the dependent. Okay, so if we take a look at another example, it says T-Mobile charges $100 plus $20 per phone line monthly. So let's go ahead and think about what the independent and what the dependent variable is. So if I write my statement here, the monthly total bill depends on the number of lines. Or if we switch it around, does the number of lines depend on the monthly total bill? So if you read those statements, this one makes more sense, that your monthly total, so what you're paying for your phone bill, is dependent on the number of lines. So the more phone lines you have, it's going to cost more. This makes more sense than this one down here. The number of lines that you have does not depend on how much you're going to pay. It's not depending on the total bill. So therefore, we would have that the monthly total bill is the dependent. So the monthly total charge, what your bill amount is your dependent, and the number of phone lines is your independent one. This is the one that we have more control over. If we only have one line, we're going to pay less than if we have 5 lines. So we can control how many lines we have. And then how many lines we have is our independent. Now, if we think about the equation for this, we would have y, the total monthly charge, is equal to, we're going to pay $100 plus we're going to pay $20 for every phone line, which is x. So this is the dependent variable. It's the one over here that's all by itself, whereas the independent variable over here, the x, okay, has to be multiplied by 20 because it's $20 per line, and then we have to add the 100. So this is our input, which our input is our independent variable, and then we get out the dependent output. Okay, let's look at one last example here. The amount of food eaten and weight gained. Let's go ahead and identify the independent and dependent variable. Okay, so if we think of our statements here, let's think about which one makes more sense. So the amount of weight that is gained depends on how much food is eaten. Or does it make more sense to say the amount of food eaten depends on the weight that's gained? So hopefully you're thinking our first statement here makes more sense because the amount of weight gained is depending on how much food is eaten. So the more food you eat, the more weight that is gained. So we have more control over how much food we eat. So our independent variable would be the amount of food eaten, and the dependent variable would be the amount of weight gained. Again, we have more control over the independent variable. So again, the amount of weight is depending, so it's the dependent variable. So the amount of weight gained is the dependent variable, and the amount of food eaten is what we can more control. That's the independent variable. So the whole purpose of learning about independent and dependent variables is for when we make our graphs here soon, we know what to put on this axis here. So the independent variable will always be on your horizontal axis. Typically, it's denoted as the x-axis if you're using x and y as your variables. And this is the y-axis. And this is the dependent variable. So if you think back to all the problems we did, now you can properly identify which axis to label with which variable.